Hey, my name is John Santaferraro, and this is The Digital Analyst, where AI makes sense and digital dominance begins.
The Digital Analyst with John Santaferraro, powered by Insight Jam.
Every major shift in the technology landscape carries with it the need for new computing architectures to meet modern requirements. AI is no exception. When data warehouse and business intelligence took center stage in the early 2000s, there was a need for more compute power. HP developed the Itanium chip to meet the needs, but Intel figured out how to build multiple processors into a single chip, and Itanium never had a chance to gain market share. When big data came on the scene in the early 2010s, I/O became the bottleneck, and multiprocessor architectures underwent a shift to include increased on-chip bandwidth and additional RAM to maximize the massive amount of data being processed at any given time. Now, as AI has arrived, the bottleneck is shifting away from I/O and back to compute. While GPUs provide a good alternative to CPUs for AI compute, organizations are challenged with workarounds necessary to move workloads between CPU and GPU technologies. So, what is happening to address these emerging needs for compute? Companies like Data Pelago have developed the concept of a universal data processing engine, a software solution that seamlessly integrates into an organization's tech stack to unify their data processing methods. The result is a versatile system designed to support all types of data, structured and unstructured, in all processors, including CPUs, GPUs, FPGAs, custom solutions, custom silicon, and most importantly, the future. I'm excited to welcome Rajan Goyal to the Digital Analyst. Rajan is the CEO of Data Pelago and the mastermind behind the idea of a unified data processing unit. So grab a glass of wine or a cup of coffee and join me on my farm right here in the hills between Lucca and Florence for the Digital Analyst. A big digital welcome to Rajan Goyal. Rajan, thank you for joining us on the Digital Analyst.
John, it's my pleasure and honor to be here. Thank you.
Hey, you know what? I'm gonna jump right in. For me, as someone who's been covering the emergence of AI over the last decade, possibly even 3 decades, there's one thing that does not cease to amaze me. It's the way that in these last 2 years, they have given us the impression that AI touches everything and everyone. And it's fascinating to watch, but also a little scary. From a technology perspective, there's no way we could be experiencing the expansion of AI everywhere without several streams of technology reaching maturity at the same time. So, from your perspective, Rajan, what's your view on the trends that needed to come together to make AI possible and possibly make it universal?
I think there are probably multiple factors, but multiple things to happen, but or are happening to enable it. But what I see is that there are two or three key things which are enabling it. One is starting from the infrastructure itself, the in the data centers, from compute point of view, from storage point of view, from networking data movement point of view. All those are catching up very fast and trying to keep up with the demands of the AI workloads, to keep it that we can satisfy the demand. So that's one aspect of the problem. The second aspect, so data center infrastructure on three axes, compute, networking, storage, have been able to keep up, or are kind of supporting the trends required for the AI. The number two is for AI, data is a fuel. You do need a context specific data or clean data or labeled data, or because that's the fuel to the system. And not only the data, but also the data processing to keep up with the demands of the AI engine is the next frontier in my mind, which will enable it. Obviously, models, the training, the quality of the model, size of the model, how long does it take to train? The commercial aspect of it is one part of the problem, which is also important. But the other aspect is how fast, how efficiently how you can process the data which is required for this AI workloads. I think that's the key part, and that's where we have been spending some time on that. And that uh, the modern infrastructure has been used or built primarily for the AI workloads, but not so much being used for the data processing. And our mission is to use the same infrastructure which is used for AI workloads also for the data processing. But those are the two, three I will mention, John, are the key ingredients required to make AI successful. Yeah.
You know, I did a little bit of my homework and took a look at your background, and your personal journey seems to have prepared you perfectly for this time in history. Can you share a little bit how you've progressed and technology progressed with you? And it's I think you're sitting perfectly at the point you are to be able to deliver some amazing new technology.
I will first say verdict is still pending whether we are able to deliver. But yes, there is a belief in that, which is that in my previous life, all along we have been doing is what's called accelerated computing or hardware software code design. Hardware software code design meaning that you, for a given software requirement or application workload, you influence the hardware to match with that requirement, right? So that's kind of generally what happens. But we are not doing hardware software code design in this life, but we are at least using those first principles to build a data processing for the using the accelerated computing. But going back to your question, yes, in the previous life we have built actually domain specific processors or accelerators for security, for deep packet inspection, for data movement in the infrastructure. So if you look at today's modern infrastructure for all the public clouds, that's all disaggregated. You have your compute racks, storage racks, or your GPU racks or CPU racks connected over high-speed network, and your east-west traffic, which is primarily major contributes the most of the traffic in the data center, is now efficiently moving bits because of the previous life we invented what's called DPU, data processing unit. But things like that have been done to bring the infrastructure to a point where it can be disaggregated, it is composable, it can do accelerated computing for security and for other applications. So we are applying the same principles for the data processing. How can we use it, take advantage of this newer infrastructure which is being vended by all the cloud providers. So in a way, yes, my previous life has prepared us to come to this point, and we are trying to take advantage of that. John.
Yeah, I've seen a similar kind of thing happen, Rajan. In my years, I started in the data warehouse world back in 1995, but having watched that, turn into business intelligence and data marts everywhere, and from there to the data lake, right? And from the data lake now to the data lake house, everything's coming back together. And especially in the last couple of years, the emergence of open table formats is finally making it possible to move towards a data architecture where you can store the data once and use it many ways. Compute coming against that one format in one place and in many ways. And that, along with the transition to the cloud, I think from a data perspective, it gives us that same opportunity of figuring out how we can actually now start unifying workloads and unifying the actual compute and work that is done. Does your technology touch on that as well?
Yeah, absolutely, John. So there are, if I may kind of break your question and slash sentence into two, three different sections. You're absolutely right. There is a big paradigm shift in the data platforms itself from a monolithic, if I may use that word, data warehouse to a lake house paradigm where you have disaggregated the data lake or the storage or the data from the execution engine. And in my previous life, if I may draw analogy from that, we did the same at infrastructure layer using the DPU concept I was just talking about, where you disaggregate the compute from storage. But it's the same disaggregation has happened in the data platform side from the data to the execution engine. If just you mark my words there. So that is already happening, and open table formats and the lakehouse concept is enabling that. So now, in order to once you're in this paradigm, that means there is no vendor lock-in. but if you play this architecture further, you can say that there is a room to have a choice of your own engine. You store your data in your data lake as an enterprise once, and then you can use a structured data engine. You could use an unstructured data engine. You can have a unified engine which can do both, and so on and so forth. Right. So, but enterprise has a choice now instead of being locked into one platform to do which can handle both data and the execution engine. So that's kind of the world we are in now. In that regard, yes, we do. Our platform is what we call unified or universal data processing engine, which is to process the data stored in single location in data lake, which could be structured or unstructured. And that UDPE or universal data processing engine is taking advantage of all the accelerated computing instances available in the cloud. We are born in cloud, and make the performance per dollar or the efficiency argument to the customer. So we run the jobs faster and with a lower TCO. But that you're right that this whole paradigm of lakehouse enable the world for to have data Pelgo to play in that, so that we can give an execution engine which is much more efficient than the existing engines here.
AI won't replace you, but a lack of soft skills might. That's the key takeaway from a new survey authored by Dr. Paula Caligiuri, founder and CEO of Skillify, in partnership with InsightJam. Over 200 tech leaders shared their insights, and the numbers are eye-opening. 93% of respondents say curiosity is essential, but nearly half don't have the time to learn. Dive into polling data and charts that reveal the biggest gaps and what tech leaders are missing about AI's impact. Download the full report now at InsightJam.com and get prepared for what's next.
It's amazing to me to watch what's happening at the intersection of data, compute, cloud, and AI, and the way that they're all coming together at this time. And that makes this concept of a unified data processing engine even possible. Can you describe a little bit more about how you're doing that for our listeners? Because honestly, I think it's the right concept. It's the right way forward, but what is it that created the need for this, and how exactly are you able to create a unified data processing engine?
So let me first give a one or two sentences on how did we land here, because that mental model or the insights are also useful to. I can give the final answer that what is universal data processing engine, what it should be, but let me give you also a little bit insights how we landed there. So the idea is that the realization is that data center infrastructure is changing because Moore's law has flattened. The general purpose CPUs are not going to improve the performance every 18 to 24 months as they used to be. So then only card left is scale out, but the scale out card is also played to an extent. Now, in order to get the better performance, you need to do something else. That is CPU plus some other accelerated computing engine. So that is a realization, kind of now the fact of the life. We have to accept that. The second part is that you have a variety of data stored into the data lake. So maybe the engine should be able to handle variety of data. What does handling means? Handling means that can you process, because structured data processing operators may be different from unstructured, and so on and so forth. So what are those things required? And the most important thing was, John, that what we didn't want to do, hence we are creating a new category of this UDPE, Universal Data Processing Engine, is that open source frameworks like Spark or Ray, in two different worlds, they have taken some time to get to where they are. So there is a maturity curve which requires, and a lot of applications and people are comfortable with that. So it was not prudent for us to build yet another new open source framework and start teaching people and how to use it and all that learning curve, right? So then the idea was that if you just look at the clean slate and say, okay, this is the world we are kind of handling with, what would be the right insertion point? So hence the birth of UDPE. So what does UDPE does? It runs on any hardware available in the cloud, or it could be on-prem, but it's here in the cloud, it is on the cloud side. It processes the variety of data types. And most importantly, it gives the life back, if I may use the word, it brings the life back to those open source or even otherwise frameworks which were designed in previous decade, but for older infrastructure, right? And older from today's point of view. It was when it was done, that what made sense. But so how do we, without rewriting it, without disrupting the ecosystem of the customer, how do we bring the benefits of this accelerated computing to existing frameworks. That was how we thought about, and the UDP does that exactly. It runs on any hardware, any data, and it accelerates or powers any engine which is available in the ecosystem today. Let me pause here, John, if this makes sense.
Yeah, no, it makes sense. I mean, so everybody that I know is doing some of their, especially in the world of AI, they're doing some of their processing on CPUs, they're doing some of the processing on GPUs, and I think some are even finding ways to use FGPAs, right? So it sounds to me like what you've done is created a platform so that the complexity of running 3 different compute engines on
Yes.
your data is suddenly abstracted away. I want to know the secret sauce. I don't know if you can tell me, but I want to know how are you doing that? Are you writing your software to interact with these different chip architectures at all the way down at the register level? Like what exactly are you doing?
Let me give a motivation first of all. How do we what you articulated in the question is absolutely true, that if we leave it to the way you frame the question, then the developers of the data platform would have to indeed deal with the hardware level details of every computing element available out there, right? So you would have to know how the FPGAs are programmed, or how NVIDIA CUDA GPUs are programmed, or how AMD GPUs are programmed, and what is the API differences. And similarly, CPUs have SIMD block, the vectorize engine, how do we program that? Or there are other processors coming up in the world with their own accelerators, because now CPUs are not just CPU, they're system on chip SoCs. So there are some accelerators there. So, or TPU of the Google cloud, or and so on and so forth, right? So that means if you don't do what we did, every data platform have to deal with this details of this, what we just went over across this processing element. So we realize this, and one of the, I would say, crown jewel of our technology is to build that virtualization layer. If I may take an example from the previous, when we were growing up, Sun invented Java Virtual Machine to move from mobile to desktop transition of the same application seamless, right? So, or VMware invented hypervisor for a multi-core devices, how to run multiple applications on the same. In the similar way, think of like in the modern world, when you have heterogeneity of the processing element, there has to be some kind of a normalization or some abstraction where people can program for that, and then that abstraction underneath deals with the details of those programming paradigm of the underlying element. So that's exactly what we did. We actually called it data VM. That data VM is a processor, but implemented in software. It's a virtual machine with its own ISA, instruction set architecture, which is domain specific. Just like any CPU, ALU have its own control instructions and arithmetic and logical instructions. Similar to that, this data VM has its own instruction set architecture, but for a domain. For analytics, for Gen AI, or for other workloads, it has opcode, it has operands, and just like any processor has it, and it has control flow, instructions as well. And inside of it has register files, input edges, output edges, exactly like what a processor would look like. But the only difference is it is implemented in software, and it has its own ISA. Underneath in that, it maps that program or the byte code to the target machine, right? So that's kind of what we have built. And as a result of that, all the details that people building data platform need not know are hidden from that, because all the details are buried into this data VM. So that's how we made it future proof. Now, tomorrow, let's say there is a new enhancement in the processor or the FPGAs or GPUs. You don't have to change the stack to take advantage of that. The data VM can kind of locally expose it to the upper layer. Let me pause here, John, if this made sense. And
No, I love that, because it everywhere that I look right now, the complexities in information technology, whether it's infrastructure all the way up to applications, is being unified. You've got unified analytics platforms in the open format, Iceberg, right? You've got unified data engineering, where all of the different data movement, data engineering capabilities are coming together on a single platform. You've got unified, business intelligence and analytics and advanced analytics and AI kind of all coming together. So this idea of unification is super important because IT organizations want to get out of the IT business. Every company is a software engineering firm. Every company is an IT infrastructure company. And the less of that they have to do and the more they can focus on their actual business, the more likely they are to actually dominate their industry using all these new AI capabilities. So that this whole idea of unification it makes sense, and now is the time for it. What does it look like from an implementation standpoint? So a lot of our listeners are, they have platforms right now and they're running on different chip architectures right now, and they're having to run different versions of data platforms because of that, and it's created a lot of complexity. What does it look like to move to a unified data processing engine?
I think the North Star here, John, is that we have single data lake and a single execution engine which can process that data, right? Regardless of the data types and regardless of that's kind of the very bold vision, or the North Star for all of us as a community. That is one end of the spectrum. Other end of the spectrum is where we are today, when you have data silos and fragmented solution. And if you double click on any enterprise IT deployment, you will find that at least 10, if not 10, 6 to 7, 6 to 10 or 7 to 10 different data solutions being deployed for streaming, for real time, for analytics, for BI and ETL and so on. So you have, right, and that creates inefficiencies, data silos, additional cost, and a lot of other complexity. And then on top of it, if you add this new dimension of heterogeneity of the server types, then it becomes much more complex to handle. So this all have to be come to a normalized form where the hardware is abstracted to a single thing, but still take advantage of accelerated computing, and then have a promise that we all want to chase, that there are no more data silos, and the single engine or or a format of the same engine can handle it. That's what we are doing. So there is one attempt from us to cover, because the assumption is that some are good at low latency and some are good at high bandwidth, some are good at streaming and some are good at batch processing. So, but those lines were carved because of the strengths or weaknesses of the existing solutions. But if you kind of expand your performance per dollar footprint, many of those functions can get consumed in single product, because now you can maybe serve the same latency needs as well as bandwidth needs. Maybe you can handle the same computation streaming as well as in batch processing. So then you can slowly start to have those lines blurred and have a unified platform service. That is kind of the technical answer to how we are chasing it. But yes, there is always the dampening factor would be, for industry to phase out the existing solutions and do that, right? And that has to be done in a way that it is less disruptive to the business. Because last thing you want to say is stop everything and then jump to new platform. It's not going to function that way, right? So as a community, all of us are kind of chasing that North Star. And as the workloads are shifting to AI, and the same enterprise data is being used for for the AI as well, and then it better be that this platform has capability to steer to that as well, right? So that's kind of how I see our role as well as the product shaping up, John.
Unlock better leads through Solutions Review events.
Welcome to Data Demo Day. Expert Roundtable, Solution Spotlight featuring Monte Carlo, Cohesity, Denodo, Cloudflare, HighGear, Broadcom, NextThings.
Boost your brand with a webinar that shares comprehensive use cases, real-time product demos, and an interactive Q&A. All broadcast live to LinkedIn, YouTube, and Zoom from our Boston studio, or even on location. Fill your sales funnel with high-quality targeted leads. And contact us today by visiting solutionsreview.com/virtual events.
I wonder if the Holy Grail is actually the acceleration towards a true autonomous software engineering platform, because we're already seeing code generation, and to me that is not that difficult. That's why that was one of the first things to pop out of the Gen AI explosion a couple of years ago. But there's an entire software engineering capability that firms have to practice in order to be able to deploy applications, that includes, product owners and architects not just for the product, but for the infrastructure and for security and for operations. And then you have all of the coding that needs to take place. And then you have all the operations engineers that actually have to run something and keep it up and running. And it seems to me that if you're able to abstract away the complexity, the life of the first of all, the life of the product owner who runs software engineering becomes a lot easier. And on top of a platform, a unified data processing engine, it seems like it would be a lot easier to arrive at autonomous software engineering. Am I out there too far, or maybe you guys have already envisioned this? What are your thoughts?
Yeah, I think I'll make one remark, which is if you wear a startup hat, you always have a vision where you would want to go, but you would have a short-term goals which are solving today's problem and get there. So if you lose track of both those perspectives, then either you keep building a product which never delivers, or you are doing a short-term projects and not tied to the end-term goal. That's kind of how you have to balance that journey.
Always
Uh,
good to hear a CEO say that.
Yes, but in this case, yes, you're right that there is enough, I would say, room for AI to influence the data platform's behavior. Many places, the configurations of the choices that you which are manually done sometimes are can be AI driven. Runtime, your optimizations which are done either through heuristics or some statistics based can be AI driven. The choice of which execution engine to use at runtime could also be AI driven. So there are a lot of room for co-pilot kind of things to embrace inside the modern data platform when we build it. So there is definitely room to do that, and that will help us because otherwise it system relies on static or compile time, if I may call, or the statistics to predict the future. But when we go to the future in the present moment at that time, then things may be different from what you thought, and then people think about how to adapt it and so on. But AI can have play a pretty big role in making the system autonomous on as well as adaptive to the situation at hand, right? And I gave you 3 or 4 examples where AI, modern AI technologies can, and some of them we are applying, yes, but we have a long journey ahead of us to realize the full vision that what we
Yeah.
can do, how we can take advantage of AI in building platforms. Yeah.
I think that's a fair answer, and like I said, it's always good for the CEO to recognize that he has to build something that he can sell today, and it's got to meet immediate felt needs. So what are some of the areas then where you're seeing traction with unified data processing engine? Where is it, and what kind of value are people getting from that?
Yeah, I think there are 2 ways to look at it, John. One is that when you are hitting the wall that you are not able to scale, so then our technology will help in terms of giving the benefit to scale of your data or the application. The second is that translates to how do we get there is because things run faster. So you are able to meet your SLAs or able to do more work within the same time. But most importantly, right now in today's world, everything pricing is consumption based. So consumption of some resources, infrastructure resources, mainly CPUs. Some people charge for data processed, some products, but mainly it is all tied to your CPU hours. And if you shrink that, then ultimately it boils down to lower TCO from the customer point of view, right? And there are other, I would say, let's call them second order benefits: unification of platform, removing data silos, easy to manage, single point of truth, and so on. There are many advantages of that. But the immediate one, the decision maker cares, oh, it's going to reduce my overall TCO substantially, and I can use that to do more work or use it for other work or whatever. But that's the immediate value that resonate with our customers right now. How do we take advantage of this modern technology to reduce my TCO, and which, as I said, just repeating myself, obviously helps them scale and work more and more data processing or something that is a benefit of that. Let me pause here, John.
Yes, and any solution areas bubbling up as more relevant to customers, or generative AI is one that comes to mind for me because of the different kinds of workloads required to actually deliver Gen AI, especially if you're combining it with agentic BI, right? So you've got structured data that you need to curate and analyze, plus you've got a lot of the textual data that is handled very well by the large language models and such, and you've got to combine them all together, and you typically have several different kinds of platforms on the back end. Somewhere you're doing some of the AI heavy lifting because the Gen AI application and the large language model can't actually do the work of heavy lifting complex analytics and what we're calling artificial intelligence. So you've got enough, people think that Gen AI is some kind of plug and play thing, but it's not. It's got all of these components. That seems like an area that would be ripe for unified data processing engine.
That is true. And as I think we discussed a little bit in the beginning of the call of our session, that all the AI solutions or the engine is relying on a quality data, right? Whether it is for training or for fine tuning or RAG, you are going to rely on the quality of the data to have the AI engine do the right work. So the data processing does play a big role in deployment of models, how fast you can do the quality of the model, how good the work they will do, and how much time and money you spend in that. So that definitely plays a role. And with our platform, yes, we do enable customers to speed up their productivity or their time to market, or making the models more relevant. So that's kind of how it is showing the value to the customer. Yes.
Well, I'm a big fan of anything that brings unification of the crazy complexity that we have created for organizations out there just trying to do business, right? Trying to stay in business, trying to improve their business, in some case, trying to dominate their market, right? And they're reliant on such complexity. And it only seems to get worse. So I'm a big fan of what you're doing, Rajan. Really appreciate you coming on to join us. And any parting words you have for our audience?
Well, I would say, first of all, thank you so much for having me. But I would say the world of data and AI is colliding, and it is getting more and more exciting, and both feed into each other. You need data to feed AI, and AI is the poster child for what you can do with the data. I mean, we have always heard of all along the tip of the iceberg as an analogy for the structured data and the unstructured data buried underneath, which is not mined or not extracting insights from that. But AI has shown a way to extract insights from unstructured data or semi-structured data, which is actually much bigger than what we see in the tip of the iceberg. That's the analogy. Now, definitely, we are in a world where it's getting exciting, and hardware or the infrastructure is also enabling us to do what was not practical before. So all the extra compute power required to do all this insight extraction is getting practical and economical in today's world. So world is getting exciting, and I'm actually very optimistic about our journey. And just stay tuned for what Data Pelagos has to offer.
Awesome. Thanks, Rajan. Thanks for tackling this big challenge. I look forward to seeing how things progress for you. Thanks for joining me on The Digital Analyst.
Thank you for having me, John. Thank you so much. Bye.
Thank you so much for joining The Digital Analyst. If you enjoyed today's episode, do me a favor and write down below if you can just like and subscribe. That would be fantastic. Go check out the YouTube channel for InsightJam.com. It's sponsored also by Solutions Review. There is some fantastic content there. There are literally 800,000 or more subscribers to that channel, and there's new content every single week. I think you'll really enjoy it. If you want to connect with Rajan, and find out more about this idea of a unified data processing unit, go to datapelago.com, datapelago.com. You can also connect with Rajan on LinkedIn, connect with me on LinkedIn for sure, and let's start a conversation. You'll find me there. Look forward to seeing you in 2 weeks for the next episode of The Digital Analyst.
Powered by Insight Jam.